It's called the Factorial Rule. And for the Factorial Rule, it actually is a extension of the fundamental counting rule. So I'm going to type something up here. So you have 9 players on a baseball team. I don't know if you guys are baseball fans. Unfortunately, baseball is not happening right now. Oh, yes, it is. Sorry. I haven't been paying attention. That's my bad. It's not the same, though. Yankee fan over here. But 9 players on a baseball team. And I want to determine how many ways I can arrange these players to come up to bat. I know somebody, her name is Bat, so I always confuse her name with this. 2 T's versus 1 T. All right, 9 players on a baseball team. I want to determine how many total ways I can arrange these players to come up to bat. Now, there's no probability involved, right? There's no probability involved with this, but I still want to determine a total amount of. So, like I said, this is an extension of the fundamental counting rule. Let me show you how. So, well, let's do it. I have 9 players. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's go with the first player. How many players can I choose to go ahead and pick the first person to come to bat? Now, again, I'm not considering any skill. I'm not considering their name. I'm not considering anything. It's random, okay? Obviously, you know, we wouldn't always do that. We would want to consider skill. But right now, we're not considering skill. How many players can I choose for the first? And I think, oh, my chat. Okay, my chat is saying what? How many players? 9 players total to choose from for the first batter. But once I put the first batter there, how many now do I choose for the second? Or can I choose to place the second person? 8 batters now. And then the third, I have 2 here, so now only 7, and then 6, and then 5, and then 4, and then 3, and then 2, and then 1. All the way down to 1, right? Obviously, order matters, right? So once I place somebody here, I can't use them again for the second. So order is going to matter, like, I can only say based on my old, so Jeter, and then A-Rod, and then, you know, Bernie, I'm sorry, old school Yankees, Bernie Williams. You know, like, the order matters, right? It's different than A-Rod, and then Jeter, and then Williams. And I'm not an A-Rod fan either, but, you know. Anyway, but I'm using him as an example. But technically, this is the fundamental counting rule. It says I could do this many ways to do this many ways to do that. I multiply it all out, boom, and I get my total amount of ways that I can arrange these batters to come up and, you know, bat. So notice that 9 times 8 times 7, I'm descending by 1 all the way down to 1, and I'm multiplying all these numbers. So this is, let me do it on my calculator and then I'll show you. So 9 times 8 times 7 times 6 times 5 times 4 times 3. Obviously, this is tedious. I'm going to show you a trick. 362, 880. 362, 880. So equals 362, 880. 362,880 different ways that I could arrange 9 players up to bat without considering their skill, randomly doing it that many ways. Now, this is the fundamental counting rule, right? It basically uses that. But there's a specific pattern involved where I'm descending down to 1 by 1. And this is also known as 9 factorial. So factorial, the factorial symbol, I know you probably have seen it, is an exclamation point in mathematics. It doesn't mean, you know, yell in mathematics. It means that I'm taking this number here and I'm using it, multiplying it by numbers, descending down to 1 by 1. 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. There is a way to do this on your calculator. Let me show you guys. Rather than just multiplying, because imagine you have 15 factorial or something like that. So if you have your graphing calculator, pull it out. Over here, you see math, my math button. I want to do 9 factorial, 9 exclamation point, 9 factorial. So in order to do that on my calculator without doing all this, I have to first press 9. Then I'm going to go into math. and this stuff pops up. Under prob, we're going to use this a lot today. Under PROB prob, I'm going to scroll over with my arrow. You're going to see the factorial symbols number 4. I'm going to scroll down to pick that up and then enter. So it says now 9 exclamation point, 9 factorial, and then enter. And I get the same thing as doing 9 times 8 times 7 times 6, da, 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 okay? So there's a trick to do 9 factorial key on your calculator. So let's just do another example. Let's say 6 factorial. 6 times 5 times 4 times 3 times 2 times 1, right? Or what's faster? Use my factorial key. Start with, you know, whatever your factorialing, that's not a word, but I made it up. 6. Then I'm going to go to math. Then I want to scroll over to prob. Then I'm going to pick up my factorial symbol by scrolling down to that one and then enter. So it says 6 exclamation point, 6 factorial, and then enter, 720. So again, I'll do one more, 15 factorial. Rather than doing 15 times 14 times 13 times 12, blah, 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 blah. 15, math, scroll over to prob, scroll down to number 4, and then enter, and then enter. That's a big one, which would make sense. 15 times 14 times 13 times 12 times 10, 11 times 10 times, all the way down to 1. So the factorial, that symbol, in mathematics, that exclamation point, that's called the factorial symbol. And it follows a specific property where, the specific pattern where whatever number's in front of that exclamation point, when you have the exclamation point after it, the factorial symbol, you take this number and you multiply it by all the numbers down to 1, descending by 1. Right? So 20 factorials, 20 times 19 times 18 times 17 times 16, and blah, 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 blah. Okay?